In this video, we will show a step-by-step tutorial on how to access and process camera images on the iOS operating system. Please use this tutorial as the preview study for my guest lecture on the iOS develop. I will walk you through the whole process in class, but it is very beneficial for you to pre-study the entire project step by step. I will mainly introduce the 3 steps for the whole video or image data processing app. That is to acquire the video or image data, and to process it and present the result to the users. There are a couple of good online tutorials covering all these aspects, but I'd like to make a tutorial here. First is because I will customize the tutorial to our particular project we will work on in the class. And secondly, those aspects are scattered in multiple online tutorials. Some of the tutorials are dated back several years ago, and the iOS and Xcode SDK system has been changed since then, and some subtle changes may hamper you from following it. Sometimes this very minor issue may cost you hours to solve. So that's the reason why I'd like to have a detailed step and by step video recorded here. Also, in the tutorial, I basically record the actual process I do the project. So sometimes I will make mistakes. Some mistakes is worthy mentioning, which can be helpful for our student. And for some key steps, I will by recording my own video, I have the opportunity to add subtitles to show you the key points there. It can also alleviate confusion caused by my somehow funny accent. Anyway, let's start. All the data process apps should consist of these steps: acquire data, process it, and present results. Of course, if you consider it more carefully, process data can consist actually of 2 steps. In the first step, you need to build some understanding of how the data, what is the content of the data, of the sensory data, which in the camera case are image pixels. And the second step is to produce some process whatever elements you find in the image and produce the result. First, let's build a single view application and choose the product name, for example, hello camera. Now it's important, we need a team here. Although in previous development and experiments, you may leave this team blank, and it actually allows you to build programs. But for our application, we want to access camera data and to do some processing, which means we need an actual camera and therefore an actual device to work with. To deploy your app to an actual device, you will need a developer's signature for security reasons. So if you do not have an Apple ID yet, apply it and get a team here. For the development language, we choose Objective-C here because we will need to link with a third-party C++ library, which means Objective-C is necessary. Even if you choose Swift here, you will need an Objective-C wrapper anyway. The device, we can choose iPhone or whatever device you have, and let's click. We do not need this stuff here. And so next, choose somewhere to host our project, and now we can create it. So this is an empty project on which we will build our app. In this project, we will mainly working in this part, the video controller implementation. Of course, for any serious app, you will need the MVC structure and to organize all the modules in the application carefully. But for this small example, I will work with the video controller implementation. For the first step, I will change the extension from M to MM, so to indicate that this C++ or Objective C++ file instead of Objective C file, because I will want to link the project to third-party C++ library. So this is the first step, and let's have a look at the way of using camera or whatever device, input devices on iOS. This figure is from Apple. This diagram shows the workflow of accessing sensory data on an iOS system. The workflow is a little bit complicated because I think it does not directly show some specific application access to some specific device. It is of a level of abstract to show the generic logic behind the work of accessing sensory data. At this abstraction level, the framework describes some essential concepts and their relationship. The central object here is a session object. AV capture session is a manager. It handles the sensory devices, which is called input, and the data users, which is represented by output objects, and their connections, the setting of the connections, and when the data becomes available, it handles all the events when to provide, when to pass such data to who, and things like that. Now we will build in our application such a structure to get access to the camera data as our first step to access to the data. In the next few steps, we will get our application ready to access camera data, following the structure we have just shown. So the first step is actually to import the entire framework. It's called AVFoundation. AVFoundation.h. I don't know why the autocomplete seems not very much working at all. Then we will need add some properties in our view controller, so the view controller have a session object, and then we will initialize the session in when the view is get initialized. The right place to do this is in the view did load. Okay, let's start by add some property. Want it to be non-atomic property, and it should be strong because the view controller is actually the owner of the session, and the session object is called AV capture. It's audio video capture, not surprisingly, session. Okay, all objects in Objective C, pointers, session. The second object that is necessary is a queue for us to for the session to dispatch tasks. Session queue. The reason we need such a dispatch queue is that when dealing with the video input resources and the data, some of the operation some of the operations are time-consuming. However, we want the app to be responsive, which means it should keep response to users' immediate input to get a good user experience. So for some of those time-consuming tasks, we would like to package those tasks and use a separate thread to process those operations. This queue is used for such asynchronization of these outsourced tasks. For now, you can consider this kind of manipulation some extra task. It is not essentially necessary for our very simple application, but this queue object is necessary to provide the session, because session requires to set up session, it is required to have such an queue object. The next step is to get the session correctly set up when the view gets initialized, which we will do it in the view did load function. But there's a whole lot of operations to do. I don't want to mess up with this function here, and let us create a new method. Void set up session. Right. We let the view did load call this new session setting up method. Self set up session. Let's bring back this figure to see, okay, there are a few objects are involved in this process. Of course, we have a session now. We will need some device, and we will need some output. We will also need the session to connect the device to the output. In the meanwhile, I think we need some manipulation of the connection so that the receiver of the data knows some meta information about the data, so it can somehow interpret the data and understand the content in the data. Okay, the first step, we'll get our device allocated. Let's have an object represent the input device. You notice quite a lot of almost all the objects involved in these processes begin with AV capture something, and for a device, not surprisingly, it should be AV capture device. Just call it video device and get initialized. One thing to notice is that this video device we represent this video device using a local variable. The scope of the variable is within this setup session function, but wouldn't in the entire life cycle of the application the input device is needed. Yes, but later in this setting up, we will handle this input device object to the session manager. The session manager, which is represented by the session property of the view controller. The session itself is a strong property of the view controller. So in the entire life cycle of the application, there is a reference to the input device is being used. So we do not need to explicitly store the reference to the input device somewhere as a property of the view controller. Let's initialize the video device. AV capture device default device with media type is what we need. Okay, we use this function signature. See, it's quite complicated, but don't worry. All the parts are intuitive. The device with okay. The next argument is device type. Is we will use AV capture device type. You notice there is a bunch of cameras which you can use. Depending on your actual device, you have many choices. What I will need here is the standard back camera. It's called device built-in wide-angle camera. If you have an iPhone 7, you may use the device dual camera, but I have an iPhone 6 Plus, so this option is not available to me. Anyway, let's use the wide-angle camera. And the device type is called AV media type video. Okay, and the position, we will use our back camera. Capture position back. So we have our device ready. The next, we will set up the input, the output, and use our session object to organize the input and output. Okay, let's set out our plan here. Set up input, then set up output, then assemble I/O using session object. Okay. Okay, in the last step of the initialization, we will actually have the session start running and start the entire life cycle of accessing, processing camera data. For the input, as in the device case, as the case of the device, we allocate the setup input using an object, which is a local variable for the setup in this function. But actually, keep in mind that this object will keep alive for the entire life cycle of the application, but managed by our session object. So the object of the input is AV capture input. Sorry, device input. Called device input. Get it initialized using capture device input. This input needs to know which device you want to collect input from. The device is the one we just set up above. The parameter's name is actually called device input with device. Okay, right. Here is video device. The input device allocation needs a second parameter to return you whatever kind of error it may encounter. It needs a pointer to an NSError object. So here we allocate some error object. Error. The note this parameter needs a pointer to a pointer. So now our error is pointer to an NSError object. Now we need the address of this error pointer. Taking the address, give the address taking operator our error object pointer. Then we are going to set out our output. The output is, as you may expect, AV capture device output. Well, oh, sorry, AV capture video data output. We call it video data output, and get it initialized using the most common way, AV capture video data output, unlock, and do the initialization. We need to specify what kind of data we are collecting. So this is done by using the output objects method called property called video settings, and the settings is specified by a dictionary. Okay, a dictionary is an object has key. It's like a dictionary. For each entry you have a key and the value for the key. The key must be unique for the entire dictionary. After you have the dictionary, you can access the items by using the key. Anyway, to set up our video settings, we need a dictionary which has a key. It's understandable that you will find to memorize all this name of the method, the key, the constant, samples, tedious and time energy consuming. You do not need to memorize them. For now, you can just sit back and watch the video, let it set in, and then watch it again following all the steps to build your example project. And in future, because you are now understand the principle behind all these operations, in future when the needs arises, you just go online, find the Apple document and find the correct reference, maybe copy and paste code template to your project suiting your needs. The key is called CV pixel, buffer pixel, format type. As we may expect it, this item is to tell the session manager what kind of data it is to be collected from this output. The value be an NS number. We use the number with integer, and the integer, call it CV. So format type, we will use the type of 32 bits. In this bit we get the BGRA data. BGRA are 4 channels for each pixel, 8 bit for the blue channel, and 8 for green, 8 for red, and 8 for the alpha channel. Alpha channel means the transparency of the pixel. So each of the channel has 8 bits. Together 4 channels have 32 bits, so it is called 32 BGRA format. Now we have the input and output. It's time for us to use the session object to construct the session object, connecting the input and output. Okay, first let us initialize the session. Note that session is actually a property of the view controller, and will have the reference to this object in the entire lifecycle of the app, and have it initialized as usual. AV capture the session log and end. Note, I discovered later I had an omission here. At the beginning of the initialization of the session method, we need to check if the session has already been initialized. If it has already been done, we shouldn't reallocate all the resources and arrange the session to organize them. We should do nothing and just return. Secondly, we want to do a little bit setup for the session object. There are a couple of different settings can be managed by session, but from these rich settings for this simple example project, we just do the absolute necessary. We set up the resolution of the video to be collected. Session dot session preset. The preset, we call it AV capture session preset. You may notice there is a lot of presets available here. For our purpose, we choose this one, which is the medium setup, medium resolution to use. Not too high, to slow down your processing process. And it is not too low that actually contains some details from the image. We can perform interesting analytics. Okay, so much for specifying the setup of the session. The next step is to actually let the setup to take effect in the session object. But there is a somewhat tricky issue here. Session acts as the input-output coordinator. It should work continuously in a coordinated way, so that the input continuously feed data to the output with some processing. But during the setting up steps, when we finish some of the steps but not the others, we may break the link between the output and the input, so the session stops working properly. How to prevent this from happening? Let's see in the following. We put all the session setting up operations in between a pair of statements. We call the session session begin configuration and commit configuration. This pair of statements renders the session setting up operations atomic. There is no session or media data processing in between these two statements, and the session comes in as an entire operating object and comes out of the setting up as a valid processing session. Okay, let's do our configurations. It's easy. Here, session, we add input over device input, and session add output, well, video data output. Okay, that's it. And we can have our session start running. The project should build and can be deployed on device by now, although there shouldn't be any interesting result to look at. But if your project refuses to build and complains that it cannot find some simple like AV capture session referenced by from some module, it perhaps your Xcode cannot automatically locate the AVFoundation and core media framework. You need to manually add those framework to your project settings. The settings is in the project setting building phrases, and when you can add frameworks in the link binary with options. We will come back to this issue later in this video lecture.